Okay, 3.4. This is our review for the upcoming quiz at the halfway point for Unit 3. Two graphs. Complete the graphs to make the function, first of all, even. Even means it will be the same on both sides of the axis. So I'm trying to make this look like a mirror image. So every point that you see, I'm reflecting that point. And if I do this, then so that gives me the even function. Odd means opposite. So if I look at this point right here is -2, +2. So the opposite of -2, +2 is +2, -2. So find that opposite point. And then if you look at this point right here with the open circle, that's -2, 3. The opposite of -2, 3 is 2, -3. So I get this point right here. And then opposite of 5 to the left is 5 to the right. And then down 1 like that. So that's what makes this an odd function. And then you also see a couple of more examples, making the function even or odd. To make this one even, I'm going to see something like this, and then it's going to go something like, let me back up, something like that to give me an even function. To make an odd function, this first point is up 5, the opposite would be down 5. Opposite of left 5 is right 5, so I'm going to connect those two dots. And then the opposite of that circle that you see right there, that semicircle, is going to be like this. That gives me an odd function. So even functions symmetrical about the y-axis, odd functions are symmetrical about the origin. If the point -7, -6 is on the graph, what points must be there to make the function even? If the function is even, I'm going to have 7, -6. That is, for the opposite x value, I get the same y value. If it's odd, I'm going to have to get 7, 6. I get the opposite y value. If a, -b is on a graph, if this function is even, I'm going to have -a, -b. If this function is odd, I'm going to have -a and b on the graph. This is probably this is the hardest part for this test. Proving functions are even, odd, or neither. So we've got a method for this. You just need to be comfortable with the methodology. F of x equal x cubed minus x. Then I'm going to write that function down again. I'm going to rewrite this. Everywhere I see an x, I'm going to put a blank parentheses. Because what I'm after next is I need to substitute in -x. And then I'm going to need to simplify this. Okay, so what I have here is f of x, f of -x equal, what is -x cubed? Keep in mind that's -x times -x times -x minus -x. That's a plus x. So look at those three negatives. Three negatives, when you multiply that, you're going to get a negative answer. So f of -x is -x cubed plus x. What I'm looking for is, do the first two columns match? Okay. When I see this, x cubed minus x, -x cubed plus x, these are not identical. This function is not even. So I must continue. If f of x equal x cubed minus x, easiest thing to do here is just to put a parentheses around everything. If I put a negative on the left side of the equation and a negative on the right side of the equation, now let's simplify. Negative f of x equal -x cubed plus x. Okay. Now I see that the second two things match. This is an odd function. This function is odd. It is odd because f of -x equal -f of x. Okay. If I had asked you, is it even, yes or no, the answer, it is not even. Why is it not even? It is not even because these two things are not equal. And it is odd because these two things are equal. So again, proving something to even, odd, or neither. Same methodology, f of x equal x squared plus x. Rewrite this with blank parentheses. Substitute minus x. Sorry, let me back up. Substitute minus x. So when I do that, I get f of minus x. So negative x times negative x, that's just going to be x squared minus x, okay? So these first two columns do not match. Now let's go to the next one. If f of x equal x squared plus x, what does negative x equal? Put a negative in front of everything. You get negative f of x equal minus x squared minus x. Okay, this function is neither. What is my reason? It is neither because I have found that f of x does not equal f of minus x, and I found that f of minus x does not equal minus f of x. Okay, so you don't have to memorize all of that stuff. You know if the first two columns match, it's even. Second two columns match, it's odd. None of them match. You have a situation where it's neither even nor odd. Another example, f of x equal absolute value of x plus 4. So this tells me that f, let's substitute in minus x. And then we have to look and say, okay, what does this mean? F of minus x is equal to absolute value of minus 1 times x plus 4. What's the absolute value of negative 1? That's 1. So this tells me that f of minus x is the absolute value of x plus 4. I see that these things are a match. So I know that this is even because f of x equal f minus x. So I don't need to go further and prove that it's not equal to f of negative minus f of x. So I proved that it's even and answered the question here. Now if I were to ask you if it's odd, yes or no, and why, then you would need to give me a reason why. And you could say it's not odd because I proved that it's even. That would be a sufficient answer there. And then you should be able to graph all 6 parent functions. I won't give you all 6 on the test, but you're going to see one of the 6. And you should be able to accurately graph this. So if you look at, I'm graphing x squared. And then answering questions about it. The vertex. This vertex is at 0, 0. Domain of this function, the set of all x values. The range of this function. The range is the only time I go to the y-axis. I don't see y values until I get up to 0. So the range is 0 to infinity. Intervals where the function is greater than equal to 0. Where is it above the x-axis? That's negative infinity to infinity. Where is the graph of this function below the x-axis? That's nowhere. Increasing and decreasing. This function, if you start out traveling from left to right, so if I travel from left to right, this function is going down. It is decreasing. So it decreases from negative infinity to 0. Always parentheses on increasing and decreasing. And then it starts to increase from 0 to infinity. You can look at the graph and tell that is an even function. F of x equal x cubed. You can look at the points here. If I graph this function, and if I look at this, it has an inflection point at 0, 0. We talked about that. That's where it changes from. When we look at the graph of this function, at this point, it's curving downward. It gets to the origin, and then it starts to curve upward. It changes its curvature. That's its inflection point. The domain, negative infinity to infinity, same as the range on this one. Intervals where this thing is greater than equal to 0. Well, that's going to be from this point on. So from 0 to infinity. Where is it less than 0? That's negative infinity to 0. Where is this function increasing? As I travel on this function, as I travel from left to right, so if I start over here going from left to right, this function is always going up. It increases from negative infinity to infinity. If it increases everywhere, then it decreases nowhere. And this is an odd function. So again, these 6, you've learned them over and over, and we've graphed them. So same thing with this one. We'll go ahead and graph this in a hurry. Absolute value of x. So the absolute value of x is there, and you can answer the questions about those. Okay, so I'm not going to work through the rest of these. We worked them in class. They've been assigned as homework, but you should be able to answer all questions related to this. So I'm going to go ahead and punt on the rest of this video. Like I said, because you can look back at when we did the 3.3 in class. But anyway, that's where we are. So you really need to be solid on all 6 of these functions, because what happens as soon as we finish this test, we start moving these functions up and down, left and right, reflecting about the axis. So I need you to be really solid on those. And if you can work through all 6 of these, you should be in good shape for the graphs that come up on the quiz.